we're supposed to do them?
Number 5 or 7, you mean? Next
Yeah,
section? Okay.
writing the expression for the general term.
You do that if it's an arith. Well, I guess you would do it if it's not an arithmetic because it'd be fun. So the first thing you want to do is figure out, is it arithmetic? If it's arithmetic, then we have a formula for it.
How do you know if it's arithmetic?
What is the definition of an arithmetic sequence that I gave you?
It's just you just add something to the previous one.
Yeah.
But it's the same thing every time.
There you go. Yep. So are you adding the same number over and over and over and over? If you're not, then it depends on the sequence. They're not going to be able to give you guys too much of difficult stuff at this point. But you just see if it is arithmetic, and then write it, and then find the 5th and 10th terms.
Okay.
Most of them appears to be arithmetic.
So you use that formula, the a
Uh,
sub n equals a sub 1 plus d times n minus 1?
And you're not checking to see. You're verifying that it is arithmetic. So you're not saying they're not asking you is it arithmetic or not. They're saying, hey, this is arithmetic. Verify that it is. So they'd want you to show a little work. Typically, they're going to ask you once we get to more sequences and stuff like that. They're going to say what type of sequence is this, and they'll expect you to realize if it's arithmetic or not. And then in some cases it could be ones like in section 19 to where it's a formula like that to where we have different things. It could be arithmetic, and then we also have section 21, which will be different types of sequences as well. So they're going to ask you what kind it is instead of verifying that it is this in some cases. And sometimes they might say, hey, verify this is arithmetic. That could be on the test, depends on what they want to ask.
So when you're writing the expression for the general term, you use the one I just said, but
you fill
what
in
is
everything.
n?
An is n, that's fine.
But like it has a sub n and also just n as a variable. What is n as a variable
Just
by
n.
itself?
That's fine. You would leave it as n.
You leave it n as okay. That's the term number. So like.
Yep.
Okay.
So generic term, just like on the ones before, they had an n in them. In some cases, sometimes they had a n squared or whatnot, depending on what it was on those in chapter 9 or section 19. Now it'll just be n because it's arithmetic. It'll just be a plain n by itself. Any other questions from the homework? Who's done any of the homework? So Abby's looked at it. Sydney's done some.
Yeah, I tried, but it was.
But it was what?
I was too busy, you know. I'll do it sometime. I'll just.
You were too busy over the course of your 3-day weekend and Thursday night, or yeah, Thursday night.
It was not a 3-day weekend. Okay, I have other classes to do, Donald.
Okay. It still was a 3-day weekend.
No, it was. Okay, whatever. Whatever. You don't know how much work these teachers give us.
I do.
It's ridiculous.
No. You signed up for
you.
these higher level classes. It's not our fault you signed up for all these classes.
You're right.
30 problems over 3 days is not a lot. And you didn't have to do all of them. You just needed to do some of them, to be honest, to see if you had questions or not. So you could have got away with doing like 7 or 8 questions, which shouldn't have taken you forever. Mm-hmm. You took Algebra 1 in 7th grade?
That's what I meant. Sorry.
You're fine. And I didn't mean back then, I meant in high school. You got to choose your classes this year. You didn't have to take all these ACE classes and things like that. You could have taken some other classes that weren't as difficult, so you had more time off. You guys chose to take on all of these courses. And there are consequences with those choices, being that you have to spend a lot of time on your homework if you're not able to just readily understand stuff. in 30 problems is not asking a tremendous amount, when most of them are literally just, hey, list these 5 things, write the first 5 terms of the sequence. They give you A1 in the difference in some cases. That's not that bad. Like, you can't complain about some of these questions. Some of them a little harder, but not all of them. A lot of them are really easy questions in this section. Okay, so anybody else? Any questions on section 20? Because if not, I'll cover section 21. So as to not waste our class time today. Okay, I will start covering 21 then.
Wait, that's it for 20? I thought you said today you were gonna do more.
I thought I finished everything for 20.
We only did I mean, I don't know. I just thought there would be more.
I'll make sure I didn't miss anything, but I'm pretty sure I covered. It's like I said, section 19 was or 20 was really short. It's just arithmetic sequences and then arithmetic sums. So you just need to know those formulas that I went over and did examples of each of the problems. I'll make sure I didn't lose anything though. So let's see, we talked about if it's an arithmetic sequences. Then we did finding, yeah, we did that. We did partial sum, so I gave you the partial sum formula. Yeah, that's everything for 20. Yeah, 20 is really short. Like 19 is like, compared to 20, 19 is like super long. 20 and then 21 is a different type, but it's really just using those formulas and knowing the formulas, because I don't think she'll give them to you most likely, so you'll have to know them. Excuse me. So yeah, that's everything for 20. No, you will not have a final. You have test 5, which I think is ridiculous, but you have test 5 and that's it. Yeah, I don't see a reason why you shouldn't have had a final and used it as a replacement, but whatever. Not my call. Okay, so moving on to geometric sequences and chapter or section 21. Okay, so as a quick reminder to the class, what was the definition of our arithmetic sequence?
Adding or subtracting the same number between two.
Okay, so in our geometric sequences, it'll be a similar concept, except we're going to be multiplying. So a geometric sequence, which I'm going to abbreviate as GS, is by multiplying by the same number over and over. We'll say by the same number each time. So the book goes through a whole little spiel and try to figure out different things and figure out what it is. It's really just arithmetic is adding and subtracting, really just adding or adding a negative number. And geometric is multiplying by the same number. And there's a nice little easy formula for it. When we talk about it, like I said, the book goes through a whole bunch, tries to get it for you. I don't really think there's a need for that. So when we talk about it, a sub 1 times r to the n minus 1. So our geometric formula for a term in our geometric sequence will be a sub n is equal to a sub 1 times r n minus 1. Some of our values have not changed. So obviously a sub n is our nth term, or our general term. A sub 1 will be our first term. N is still the number. So nth term or our general term. A sub 1 is still our first term. N is the number, so we still have that. This time, though, we have an R. R is our ratio, and that is what we are multiplying by each time.
I have a quick unrelated question to the grading.
Okay, go ahead.
So she's dropping our lowest test grade, right?
As far as I am aware, yes.
So when you add the other 4 test grades to get your average after she drops it, do you still divide by 5 or do you divide by 4? Is it like she's giving you like do you understand what I'm saying?
Yeah, you'll have 5 test grades, you'll drop 1, and then you'll have 4 test grades, so you'll only use it as 4. So that number divided by 4. Okay. So there is your generic term, what your n and everything is. The only thing different now is with geometric, because we're multiplying over and over. That's like saying 5 times 5 times 5 times 5 times 5. That's where we get that exponent of n minus 1 from. Okay, so Abby brings up a good question. Can it only be multiplication or could it be division? Again, this is where we have to be careful. There is actually no such thing as division. There is only multiplication. Just like there is no such thing as actually subtraction, there's only addition, adding of negative numbers. So instead of saying division, what we actually are doing is multiplying by a fraction. So what a lot of people don't realize is dividing by 2 is the same thing as multiplying by 1/2. There really is no such operation called division. It's only multiplication. Think about back when you did long division, what did you do? You multiplied the 2 numbers on the outside to get to the inside. You never actually did this thing called division. There is no such thing as division. It is just multiplying by fractions. So we call it division to make things simpler and easier in understanding, and we have a division button and everything, but really what it's doing is multiplying by a fraction. So if your ratio is we'll talk about specific types of ratios, whether it be positive, negative, fractions, etc., what's going to happen to our functions. But yes, you can have that stuff. All right, so we'll just jump into an example real quick. So 4 8/3, 16 ninths. So if we have 4 8/3, 16 ninths, dot, dot, dot. So here we have to ask ourselves first, is this a geometric sequence? Now, obviously, in this section, most of them are going to be geometric sequences. However, we also have to consider when we're taking tests and things like that, we have to check what kind of sequence or series is this. So is 4 8/3, 16 ninths, is that a geometric series or sequence?
Yes.
Okay, then what is our common ratio? What are we multiplying by every time then, Madison?
2.
You kind of broke up there, sweetie. What'd you say?
What? Oh, is it 2/3?
It is 2/3, very good. So an easy way to do this, what I do as a suggestion, if you have a bunch of fractions, is make the first one 4/1, then 8/3, then 16/9. Then, only look at the tops and only look at the bottoms. Are they being multiplied by the same thing over and over? So 4, then 8, then 16. Am I multiplying by the same thing over and over? The answer is, I'm going to assume, hopefully everybody sees yes. Multiply by 2. And then on the bottom, 1, 3, 9. Am I multiplying by the same thing over and over? And again, obviously, I'm going to assume everybody sees that the answer is yes. You multiply by 3 every single time. So our R will be 2/3. Does that make sense, hopefully? Everybody see that?
Yes.
Okay. Now they want us to find the 6th and 9th terms. So what is a sub 6? Oop. And what is a sub 9? Well, very easily, since we have our ratio, we have our starting term, we can just apply the formula that's given to us above. So a sub n will be equal to a sub 1 times r n minus 1. So a sub 6 will be equal to a sub 1 r to the 6 minus 1. So a sub 1 we're going to get from our sequence they gave us is 4, r is 2/3, and 6 minus 1 is 5. And then we get to do the same thing with 9, except we're going to replace that with an 8. And I'm going to safely, hopefully, assume that everybody can plug that into their calculator properly with fractions and exponents.
Can you tell us what the answer is just to make sure? Hello, O'Donnell, we cannot hear you speaking. Please stop doing a problem. We can't hear you.
Can you hear me now?
Yes.
Okay, thank you for saying something. When did I cut out?
A long time ago.
A while ago.
Like, at the end of the last problem.
Okay. So thank you for saying that, or telling me something. So, does anybody have any questions about the last problem then?
What are the answers, just so we know?
Hold on, let me pull it back up. So a sub 6 was, let me find it, 128 over 243, and then a sub 9 is 1024 over 6561.
Okay.
So then moving on, sorry, to the next type of problem. So sometimes they're going to ask you to find the number of terms in the sequence. And this can be helpful because it may not just be, hey, how many terms are in the sequence? They may be asking you to find like the sum, like we did looked at with arithmetic, and you need to know how many terms are in the sequence. So sometimes that's going to be an important question that may not be just a question, but you need to figure that out to be able to do different things like the summations and stuff like that as fractions. So it's just the numbers, Olivia. So if they give us, in this question that they've posed to us, they tell us our first term is 5, our ratio is square root of 2, and then our a sub n is 320. And they want to know how many times do I need to multiply by the square root of 2 in order to get to 320. So pretty straightforward. We get to use our formula. So we get that a sub n is equal to a sub 1 times r to the n minus 1. So we're going to plug everything in. So we get 320 equals 5 square root of 2 to the n minus 1. The problem with this one versus the arithmetic one is, where is my variable that I'm solving for?
In the exponent?
In the exponent. Well, how do I get something out of an exponent?
Nope, that's wrong. Never mind. It's not taking the square root, right?
No, it's not taking the square root.
Okay.
Oh man, Olivia figured it out.
Oh my god.
Oh my god, it's logarithms! It's like we learned something so we could use it on other stuff. Oh wait, we did. They're not that bad. So we are going to have to use logarithms again. Yes, anytime you want to get something out of an exponent, for the most part, you will use logarithms. So we have to solve this equation and then change it to logarithm form. In order to do so, we need to use logs and stuff like that. So the question is, what do I do first? Because I have to do something before I can use my logarithms.
Don't you do something with the -1?
Not necessarily, no.
Okay. Oh, the 5. You divide by 5.
So that would be a good start. We do have to get the thing with the variable by itself. So before now, because we didn't have exponents or variables in exponents, we would just say, oh, get the variable by itself. Well, now we have to get the thing with the variable, so the square root of 2 to the n-1, we have to get that by itself. So anything that's not directly attached to it, so the square root of 2 and the n-1, that all has to be moved somehow. So in this case, we'll have to divide by 5. So it's at 64 is equal to the square root of 2 to the n-1. Now there are multiple options here you could use to solve this problem. There are different techniques, so if you ever find something online where they do different things, there's probably about 4 or so ways to solve this problem. The easiest one is to go ahead and take the log of both sides at this point. As soon as you have your thing with the exponent by itself, you would take the log of both sides. Instead of taking the log, I'm going to take ln, because that's typically what we do. We like to use ln versus a log in most cases. So almost any time, if you ever go on to higher level math, anytime they say log, they mean ln. Like, it doesn't matter what they say. So if it says log of both sides, it means ln. This is always what we use in high math. So what's the point in me taking the logarithm of this right-hand side? Why do I do that?
You move the exponent out in front.
Very good. The reason we do this with exponents is because when we take the log, if it's something along this nature here, I can move that exponent out front. And then I will caution you, make sure you put your exponent in parentheses, especially if it's something along the lines of n-1, which clearly with these types of problems, it will be n-1. Okay, what would my next step be?
Divide
By...
ln 64?
Nope.
n-1?
No.
The log of like ln square root of 2.
Remember, I'm trying to get the n by itself, so I need to get everything else out from around that. So I'm going to divide by
Yeah.
ln square root of 2.
Wait, divide by the square root of 2 or ln square root of 2?
ln square root of 2.
Okay, you cut out, so I couldn't hear.
Oh, sorry. Yes, divide by ln square root of 2. Okay, I'm going to move up to the top right now, so then we get ln of 64 over ln square root of 2 equals n-1. And my next step would be?
Subtract. Add 1.
So add 1 to both sides. So this you put in your calculator, you should get 12. And then add 1. So n equals 13. Makes sense. For now. Any questions on what I did anywhere, please make sure you ask them. Okay. Do one more like that. 1, -2, -128. Okay, so now they're giving us that our first term is 1, our r is -2, and our a sub n is -128. So fortunately, setup is pretty much identical. Nothing's really going to change there. Our a sub n is equal to a1 times -2 to the n minus 1. Yes, Olivia, 13 is the final answer, sweetie. Okay, so what would I do on this problem?
Divide by 1.
Divide by 1,
You-
which doesn't do me any good, so
I know, you don't have to do that. I was making sure.
no, you're fine.
Okay.
So really, you don't need to even put it there because our first term's 1. However, I usually write it out on my first step. Okay, so what would I do
then you
next?
would just the natural log.
Okay, so then I would do natural log. So that would give me ln of -128 is equal to ln of -2 to the n minus 1. Is everybody okay with me doing that? Everybody understand?
What are we understanding?
That took the log of both sides, make sure everything's good, everybody agrees. Nobody sees
Okay.
any issues, has any questions.
Wait, I thought that you couldn't take the ln of a negative number.
Thank you, Miss Brisa. That is correct. And Miss Olivia, I don't know if you knew that or just were asking to do something with negatives, but yes, you cannot take the ln of a negative number. That is not a possible problem that we can do right there. However, we can do the problem, just not the way we have it set up. So this line right here where it says ln of -128 is not acceptable. I cannot do that. I cannot take the ln of a negative number.
Can you take the log of a negative number?
Same thing.
Okay.
So the question is, as Miss Olivia asked a second ago, can I do something with the negatives? And the answer is yes, I can. And in fact, I have to. Anybody have any suggestions?
Divide by a -1.
Divide by a -1. There's a issue with that though.
Which is?
If I divide this side by -1, this side over here then has a negative on it, and I can't put the negative inside of my parentheses there. So if I do, for instance, -2 to the n minus 1 over -1, this -1 can't go into that set of parentheses.
Okay.
That would not be allowed. Okay, this problem actually takes a little bit of understanding versus just doing math. This is where I talk about those problems. If my first term is positive and I'm looking for a negative final answer, what does that mean about the number of terms in my series or my sequence?
It's the alternating one, right?
It would be alternating because I'm multiplying, but how many terms could I possibly have in my series?
An odd number.
So careful. What would the first term be? Obviously 1. So it's a first term is
Positive.
positive 1. Second term, because you can write out a couple of them, would be
Negative.
third term would be
Negative.
etc., etc. How many terms will I need to have in my series for the final answer to be negative?
Odd amount.
Careful. Which terms would be negative? Look at the series I started to write out. Which terms would be negative?
Oh, the even ones.
The even ones. So that automatically clues me in to my answer has to be an even number in this type of series. If it's not even, I'm not going to have a negative number. So it's things like 2, 4, 6, 8. It's got to be one of those. Otherwise, I'm running into issues. The way we deal with this issue is we go, okay, I know it's going to be even. I know it's in order to get negative. So because I'd be running into issues, we can ignore the negatives because we have an understanding that I have to have an even number there. That even number means I get to ignore those negatives. I'm not just dividing by -1. That is the biggest thing. Do not show a division by -1 on both sides. That is not what we're doing. We are looking at this and going, oh, okay, well, if I had instead changed this to start at 2 and be going to 128, it's the same thing as starting with -2 and going to -128 because it's an even power. That will get me to the same place. That is what we're doing. So we get to ignore those. Now, if this had not been set up in this way, we cannot just ignore the negatives, but because the way this problem is set up where these are both negative, and I realize that I'm using an even power, then I can do this method. And now I can take the ln of both sides. And it becomes pretty much like the last problem. So ln of 128, bring our n minus 1 out front in parentheses. It's very important we keep that number, that n minus 1 in parentheses, otherwise we will make some mistakes. Divide by our ln of 2. And we get ln of 128 over ln of 2 is equal to n minus 1. I think that's 7. 7 plus 1 equals n. N equals 8. Yes, it is 7. Okay. Does everybody see what I did? Anybody have any questions on how I did or why I did anything?
So what happens if it's not even?
Then we either would have A, started with a negative number here, so we could have like started with this being a negative,
Okay.
and then other compensations will have to be made. So you want to look at that and see what's going on. It would have been an odd number at that point, and again, we would still kind of get at the same kind of end up being the same conclusion, is that I just need the number of terms. I don't necessarily need the negative part. So how do I get from 1 to 128? The negatives will have to be taken into consideration. So for instance, here with this series, this could not possibly be a positive 128 because I start at 1. So that's not we can't just say, oh, it could be positive or negative. It has to match up. If they don't match up, then that's not going to be a possibility to work the problem out. So they're always going to match up. It's not like, oh, does it match up or not? It has to. So if I start with a negative and I end with a negative, then I have to have odd numbers of terms. If I start with a positive and I end with a negative, I have to have an even number of terms, etc. Those two things will always match up for you.
So could you get it right just by writing out the terms? Like,
You will not get credit for that, no.
okay.
Yeah, they want to see the work and the LNs and stuff like that. Now, could you do that to check yourself? Yes. Do I suggest doing that? Unless you get an answer like n is equal to like 100 or something like that, then yes, I do suggest at least figuring out, did I do this correctly by multiplying by the same number over and over and stuff like that. But I definitely suggest checking it. But you gotta actually do the work and solve the equation to get full credit.
Is that it?
On that problem, yes.
Oh.
For the lesson, no. Okay, any questions on that one? Okay. Okay, so A6, I think it was A6. A5 is 6 and A9. Okay, so other ways they could look at problems and do things is they can give you a couple of terms. So specifically here they gave us A sub 5 and A sub 9. and they want us to find the first term and the common ratio.
Is that 9 or 6?
Where?
It's like, it's a sub 5 and a sub what?
9.
Okay, I just couldn't tell.
Okay, so this one is probably what I consider the more difficult ones of this section. So we have to ask ourselves, why did they give us these two? And then ask for those two. The reason they gave us the two terms is because we're solving for two variables. And anytime I have two variables, I need anytime you're solving for two variables, you need
Two terms.
not two terms, but
Two equations.
two equations. It'll be a system of equations. Anytime you want to solve for two variables, you need two equations. Three variables, three equations, etc., etc. So that means these two are going to give me equations. Well, I could write a sub 5 as a sub 1 times 5 r to the 5 minus 1, or as a sub 1 r to the 4th. And I can write a sub 9 as a sub 1 r to the 9 minus 1, or it's a sub 1 r to the 8th. And I now have two equations with two variables. Very specifically, I have 6 is equal to a sub 1 r to the 4th, and I have 486 is equal to a sub 1 r to the 8th. So now the question is, how do I solve a system of equations that looks like that? No, this will not involve matrices.
Do you log?
No, I do not. Definitely do not want to involve logs. If I had one singular equation like we looked at on the previous examples, yes,
Elimination.
logs.
Can you use elimination?
Unfortunately, elimination is not a suggestible option. It is an option, and some problems do work out that way, but I do not suggest elimination.
Matrices.
Substitution.
Definitely not matrices, because I just said no matrices. And yes, a couple of you figured out. I would definitely suggest substitution here, and then go from there. So you can pick to choose whichever variable you want. You can either solve for a sub 1 or r. It's your choice. I'm going to give you a hint. With exponents like this, it's typically easier to solve for a sub 1 first. So what I mean by that is a sub 1 is equal to 6 over r to the 4th, and it's equal to 486 over r to the 8th. Once I have solved for my easier variable, which is a sub 1 in my opinion, so this is how I would do it pretty much every time, what can I do with those two equations now?
Set them equal to each other.
So I can set the right-hand sides, careful, equal to each other. So I get 6 over r to the 4th is equal to 486 over r to the 8th. And then at that point, to solve this is now a proportion. To solve proportions, your teachers probably would have taught you something along the lines of the butterfly method, cross-multiplying, etc., etc., however you want to think about it. So bring the r8 up here, so you get 6r to the 8th, r to the 4th. Now the question would ask ourselves, how do we solve that equation?
First divide by 6, and then divide by r to the 4th.
Okay, so you can divide by r to the 6th. I'll allow that. I don't know what 486 over 6 is, though.
Wait, what?
I said I don't know what 486 over 6 is, though.
81.
Thank you. Okay. But then you said divide by r to the 4th. Do we agree with dividing by r to the 4th? So Abby says yes. Anybody else have any thoughts?
I said it.
Well,
but
clearly. Anybody
Yes.
else have any thoughts on dividing by r to the 4th? He's typing something. Yes, if you divide it by r to the fourth, it would be r to the eighth over r to the fourth. The question is, can you divide by r to the fourth? And the answer is
Since you're saying that, probably no.
no. Two things. You can, on this problem, divide by r to the fourth. Can you generically divide by r to the fourth? And the answer to that question is no. What is the issue with dividing by r to the fourth? I'll give a bonus point to anybody who knows. Okay, I'll give you a hint. No, that's not why. So I'll give you a hint. What are you not allowed to divide by? Come on, I know you guys know this part. What are you not allowed to divide by? In a fraction, what can you not have on the bottom?
0.
0.
So what are you not allowed to divide by?
0.
0. Do we know what r is?
No.
Could it be 0?
Yes.
Generally speaking, the answer is yes. In this problem, can r be 0?
No.
No.
No, because we know that the ratio, it has to be a number because it goes from 6 to 486. So clearly the answer can't be 0. However, we don't want to say, oh, in this case I can do this, in this case I can't. You want to solve this problem properly, so we obey our rules of algebra, and instead of dividing by r to the fourth, you want to get it all to one side, set it equal to 0, and then...
Oh.
And then... After you get it all set equal to 0, and then... The answer of yes is not correct. Definitely not complete the square.
Okay, well, I have no clue.
You just factor it.
Oh.
And you can factor out that r to the fourth. So then you get r to the fourth times r to the fourth minus 81 equals 0. How do I solve that equation? No, I'll leave this there for a second.
Can you divide by r to the fourth now?
No. Anytime you have two things multiplied together set equal to 0, what do you do to them?
So each of them equal to 0? I don't know.
Yes, that would be correct. Don't say I don't know.
Oh.
You set each of them equal to 0. We've done this, I don't know how many times. You guys know how to do this. Once you factor, if they're set equal to 0, only if it's equal to 0. Now, this is where we get that solution that doesn't make any sense. Can r equal 0?
No.
No. That would be why, see, r does equal 0 in one case, which is why we're not allowed to divide by r to the fourth over here, algebraically speaking. Now, if we know r can't be 0, that gives us a bad answer, because that makes no sense for our problem. So by doing this problem, we have said r can't be equal to 0, which is why we would have been allowed to do that, yes. But mathematically speaking, we want to do it the proper way. It takes an extra second or two. It's not a big deal. We then do solve this r to the fourth minus 81 equals 0. So how do I solve that?
Take the fourth root. Well, put 81 on the other side and take the fourth root.
So r to the fourth equals 81, and then you can take the fourth root of both. And you get
How
that
do you
r
know?
is equal to 3.
How do you know if it's 3 or negative 3?
So that's a question we'll have to talk about in a second. So the question is it positive or is it negative? So we have to ask ourselves, going from 5 to 9, if it was negative, would I still get this answer here? Or would I get a positive answer? So if you have, so a sub 5, so we'll do it as positive, negative. Okay, so I'll do 5, 6, 7, 8. So if 5 is positive, 6 would be negative, positive, negative, positive. So could r be negative 3? Is that okay? Would I still get the number I'm looking for?
Yes.
And the answer is yes. So how do we know which one it is?
You don't.
You don't.
Wait, wouldn't it be
You just
wouldn't
put
it be
plus or minus 3? No, because then
You're correct. By the way, Maddie, you would put a
you
plus or
just
minus
put,
3. Mm-hmm.
but then your a sub 6 term could either be
Negative or positive. Yes, but we're not asking for the a
so
sub 6 term. We're asking for the a sub 1 term. So now we go backwards and we say, okay, so 4, 3, 2, 1. So negative, positive, negative, positive. Notice how if I did have a negative term, my first term would be positive, or if I had a positive term, it would be positive. So your R value here can take on either value. With our given information, we don't know which one it is. That was a good catch. I was waiting to see if anybody thought about that. Remember, when you take the square root, the fourth root, etc., you do need that plus or minus. Unless the problem somehow gives you more information that they say, oh, R is positive, or something along those lines, we don't know if it's positive or negative. No, negative 3 to the fourth power is a positive 81. So if you have 4 negative 3s, 4 negatives makes a positive, Miss Abby. So our R will be a plus or a minus. Also, when we go back into solve for our a sub 1 terms, notice that both my R to the fourth and my R to the eighth, that will turn it into a positive value, telling me that both my values for a sub 1 are positive, which is correct. If my R needed to be different, then I would get different values for them and stuff like that, so you have to be careful.
so
Okay.
how do you find the first term?
You plug it into the formula you have above. See where it says a sub 1 equals either of those two? You can use either one to plug into it. And clearly it doesn't matter if you plug in positive 3 or negative 3, you will get the same answer. So just pick whichever one you want. I would just do the top one because it's smaller numbers. So a sub 1 is equal to 6 over 3 to the fourth, which is 6 over 81.
Um,
Did you have a question, Metal?
oh, never mind. You're using the, okay, never mind. You're using a different formula.
I used the ones we solved for above, since we already had a solved equation for a sub 1, because we had a sub 1 equals blah.